Everyone, I am Mrs. Priyanka Udge, Assistant Professor, Department of Electronics and Telecommunication Engineering, Walchand Institute of Technology, Solapur. Today we are going to learn the application of IC 555, that is Astable Multivibrator using the timer IC 555. These are the learning outcomes. At the end of this session, students will able to learn generation of rectangular waveform without triggering and application of timer IC 555. These are the contents: introduction, block diagram, input and output waveform, expression for T on and T off. For this, recall the timer IC 555 which we have learned in the previous lecture. So, in the IC 555, we have used the 3 comparators, 1 flip-flop and 1 discharge transistor. So, in that, according to the comparator's output, the flip-flop will be set and reset, and according to that, our output will be low and high. So, same basic concept is going to use in the Astable multivibrator. This is the block diagram of Astable multivibrator. It can be designed by adding 2 resistor RA RB in the circuit like this, and 1 capacitor C with this resistors in the timer 555 IC. See, this is the circuit diagram in which the same IC 555 block circuit diagram we have used, in which upper comparator is there, lower comparator is there, flip-flop and discharge transistor is there. For controlling the T on and T off time, here we are going to add 2 more resistor R1 and R2, we can call it as RA and RB also, and 1 capacitor C. So, with the help of this capacitor, we can adjust the on time and off time of the Astable multivibrator. The basic objective of an Astable multivibrator is to switch the output status from high to low and low to high. So, it will be depends upon the capacitor charging and the discharging. Capacitor C charges towards the VCC through 2 external resistor used, that is RA and RB, until it goes above the 2/3 VCC. This voltage is the threshold voltage at pin 6, which drives the comparator 1 to trigger the flip-flop. That means the flip-flop output will be low, high depending on that. So, the output at pin number 3 goes low. Now, when this discharge transistor is driven on, causing the output at pin 7 to discharge the capacitor through resistor RB. So, here we can say that the capacitor will be charged through the resistor RA and RB, and it will be discharged through the resistor RB. The capacitor voltage then decreases until it drops below the triggering level 1/3 VCC, because 1/3 VCC is given to the second comparator. The flip-flop is triggered so that output goes back high and the discharge transistor is turned off. So, capacitor can again change through the charge through the resistor RA and RB towards VCC. Now, what is mean by on time? It is a time for which the timer output Vout has remained in high state, that is up to the 2/3 VCC. When it reaches input, then our output will be at the VCC. We note that this time is called as a T on or a T high time. Second one is the off time. It is the time for which timer output Vout has remained in low state. We note this with the T off or T low. Now, this T on and T off are dependent on the values of RA, RB and C, which we have used in the Astable multivibrator. See, this is the output waveform. Here, the capacitor will be charging from this 1/3 VCC to 2/3 VCC. Okay. So, charging via RA plus RB, and here when capacitor discharges, it will be discharging through the RB. Okay, and again it will be discharging from 2 by 3 VCC to 1 by 3 VCC. So, this is the charging time, this is the discharging time. We can call it as a T on and T off time for the output, because when the capacitor is charging, the output will be at plus VCC, that is at high state, and when the capacitor is discharging, the output will be on the low state. So, that is why it is called as a T off time. This is called as a pulse width, means width of that pulse. Here we have to calculate the voltage across the capacitor at an instant during a charging period, which is equal to Vc is equal to Vs 1 minus e to the power minus t by Rc. Second, voltage across the capacitor at any instant during a discharging period, that is given by Vc is equal to Vco into e to the power minus t upon Rc. Here the time taken by the capacitor to charge from 0 to 1 by 3 VCC. So, for that here we have to put 1 by 3 VCC. Okay. After solving this above equation, we will get the value of the T1, that is equal to 0.405 Rc. The time taken by the capacitor to charge from 0 to plus 2 by 3 VCC. So, for that here we have to put the 2 by 3 VCC, which is equal to VCC into 1 minus e to the power minus T2 upon Rc. So, after solving this above equation, we will get value of a T2, which is equal to Rc log E3, which is equal to 1.0986 Rc. So, here time taken by the capacitor to charge from 1 by 3 VCC to the plus 2 by 3 VCC, it is the difference between the T2 and T1. So, Tc is equal to T2 minus T1. So, we have to put both the values of T2 and T1 here, and after calculating we will get the value, that is 0.693 Rc. So, here the charging time Tc is equal to 0.693 Rc. Now, here we can substitute the value of R, because it is the charging time, with Ra plus Rb in above equation. So, we will get T high, which is equal to Tc, which is equal to 0.693 Ra plus Rb into C, where this Ra and Rb are in ohms and C is in a farads. The time during which capacitor discharges from 2 by 3 VCC to 1 by 3 VCC is equal to the time the output is low. So, Vc is equal to, that is a discharging time, 2 by 3 VCC e to the power minus Td upon Rb into C. So, here we have to substitute Vc is equal to 1 by 3 VCC and T is equal to Td in the above equation. So, we will get this equation 1 by 3 VCC equal to 2 by 3 VCC into e to the power minus Td upon Rb into C. After solving it, we will get the delay time, that is T, or T low time, which is equal to 0.693 RBC. Now, if we have to calculate the total time period, that is T is equal to T on plus T off or T high plus T low. So, we have to add here T high and T low values. So, we will get final equation for the total time period T is equal to 0.693 in bracket Ra plus twice RBC. So, if we have to calculate the frequency, we know that frequency is the reciprocal of the total time period T. So, F is equal to 1 by T. So, when we put this T value in the denominator, after calculating we will get 1.44 divided by Ra plus twice Rb into C. So, this is the expression for the total time period T and the frequency F. So, with the help of Ra, Rb, we can vary the time period T on time, and with the help of Rb, we can vary the T off time. So, these are the references. Thank you.